Hello everyone, this is Anirudh Mathuria, Vice President from Ixia. I'm responsible for product development in the area of network test, and today I would like to tell you about software defined networking, or SDN for short. Software defined networking is the most transformational and profound paradigm shift the networking industry is facing today. The approach is to decouple the control plane from the data plane and introduce software-based centralized network control. This technology promises huge leaps in efficiency, agility, and flexibility in operating and scaling modern networks. Traditional networks have been architecturally complex and less flexible with respect to business demands. The maintenance of these legacy networks required higher CapEx and OpEx, mainly due to vendor-locked ecosystem. SDN solves this problem through flexible network design and open architecture, enabling innovation and differentiation. The disruptive set of changes introduced by SDN starts with simplifying configuration from device level to the network level. The configuration time reduces from weeks to minutes, accelerating new feature and service introduction. Increasingly more complex and virtualized application with greater agility and lower cost is driving a wave of change in data networking. SDN provides network level control to the applications running on top of it, making them even more powerful. For example, Link can dynamically reserve the bandwidth required for a call. One of the important contributions of SDN is network programmability, achieved by changing the network device architecture from monolithic to decoupled data and control plane. Finally, open standard-based and vendor-neutral architecture enables technology innovation and differentiated service offering. As SDN emerged in the last couple of years, we have seen a lot of proof of concepts for different approaches as well as debates about the realistic use cases. SDN has remained in the peak of inflated expectation as per the Gartner hype cycle during this time frame. But as the technology matured, SDN has started moving from lab network to deployment for the data centers, carriers, and enterprises. We have seen a huge proliferation of SDN solutions from not only the traditional network equipment manufacturers, but also the startups from the beginning of this year. One of the important factors driving this trend is the maturity of the technology. Evolution of multiple technology approaches and the success of few early SDN trials gives the adopters different options to play with. Some of the carriers such as Telstra, NTT Communications, and Verizon Enterprise Solutions have launched leading-edge SDN-based services. The industry analysts think that such launches will serve as the catalyst for the other operators to finally take the plunge. Real-world SDN success means revenue generation. With the non-disruptive approaches of SDN becoming popular, network operators can now build long-term realistic migration strategies and recognize ROI at every stage. The important factor is the network function virtualization revolution along with the DevOps mindset. Strong synergy with these complementary trends is introducing an operational shift towards SDN, which enables the service providers to bridge the gap between IT demands and network services. As per TBR research, the spend towards SDN adoption will grow at a very high rate 2016 onwards. According to their latest enterprise SDN market landscape, SDN is approaching adoption by an early majority of enterprises and will compose nearly 40% of global enterprise network infrastructure revenue by 2020. From the above trends, it is obvious that SDN is crossing the chasm now and the adoption is accelerating. SDN was born in universities and brought up in the data centers. The initial flavor of SDN centered around OpenFlow protocol. In OpenFlow SDN, the network paths are defined as flows in the forwarding devices. The controller uses OpenFlow protocol to install flows in the switches. One of the advantages of OpenFlow SDN is the low-cost white box switches which bring down the network cost. But this approach of SDN requires forklift upgrade of the existing infrastructure and therefore costly from migration perspective. OpenFlow SDN is popular among data centers and campus networks, which are mostly greenfield deployments. As SDN gained popularity over time, the forklift migration nature of OpenFlow SDN became a barrier for adoption for the service provider networks who have huge investment in their existing infrastructure. The evolutionary approach focuses on building SDN on top of existing routing and switching infrastructure. This makes use of existing forwarding plane with technologies like segment routing and PSAP. This mode of SDN is more popular among carrier as well as the enterprise networks. With multiple approaches evolving, different types of networks are able to benefit from the SDN applications. SDN is beginning to change how networking is done in the core and access networks as well as in the data center and enterprise networks. The approach and the technologies are different for every type of network based on their unique requirements. But in each case, SDN needs to seamlessly work across physical and virtual infrastructures introduced by the recent proliferation of network function virtualization. Finally, based on the business need of different network types, the applications are also different. For example, a service provider benefits from dynamic network provisioning and service insertion for the core network, while the data center finds the value in being able to build multi-tenant network infrastructure. On the other hand, enterprises are able to achieve application scale and agility through software-defined WAN. Every new technology comes with a lot of unknowns, and SDN is no exception. Adoption of SDN comes with a lot of promise. At the same time, it is a challenge for the adopters to quantify the benefits, understand the practical migration steps, and measure success. They need to justify at every stage whether the solution is able to deliver the performance, resiliency, security, elasticity, and quality of experience needed to satisfy their customers. It is important for carriers and data centers to do proper validation at every stage of their network life cycle. During the vendor selection process, it is important to ensure controllers' ability to support the scale of underlying network infrastructure and at the same time measure controllers' latency or performance in decision making. For selecting the right switch vendor, one should measure the flow table capacity of the device and the forwarding performance. Interoperability is a major factor during the network design phase that needs to be taken care of. One should validate controllers' ability to interpret and translate the northbound application level instructions into network level instructions at large scale. Delay to generate correct southbound instructions by the controller or delay introduced by the switch in following southbound instructions can make or break the network overall performance. The SDN ecosystem is made of multiple technology pieces which needs to work in tandem to achieve the end goal. During the deployment stage, the carrier or the data center must validate end-to-end functionality. That is, ability of the system to learn the right underlying topology, provision network path, and dynamically adapt to network changes. The performance benchmarking of the traffic characteristics like latency or jitter and the measurement of convergence time of data traffic in case of a network failure are other aspects of validation at this stage. To execute these steps, network engineers need the help of a tool which supports end-to-end validation with comprehensive coverage for all the technologies in the SDN ecosystem. Ixia offers its industry-leading experience in network infrastructure validation through the SDN portfolio of IX Network. Top carriers and data centers trust Ixia as a validation partner in their journey with SDN. Friends, this is end of my presentation. Please watch our subsequent videos for further information. Thank you.